Alright, so let's look at adding, well, first of all, let me show you what we got. So now we have a texture image, and this will load any kind of image we want onto our cube, which is really cool. And it's running slow because I'm running in a virtual machine, and because I'm recording. But normally this is really fast. And we're going to look at how to do this. Also added CD capabilities to this too. So we'll also look at how to do that too. So just continuing on with your previous project, where we left off with CE, which is the Crazy 80s GUI here, CE GUI. And we're just going to come down here and we're going to add our SDL CD pointer, and we're going to do an int for the track. And then we need to get into our function here that's going to define our loading. Now, real quick, coming back up here, there's a library that we need to include, and that is this SDL image here. So don't miss that one. We need that image, otherwise this is not going to work. As you can see them right there, that's all three of them. So yes, we absolutely need that, otherwise this isn't going to work. Something else we'll need to do is to deal with the compiler directives. So if I go to my linker settings, my linker libraries, I need GL, GLU, SDL, SDL main, CE GUI base, CE GUI OpenGL renderer from before. And for whatever reason it keeps dropping my other ones I keep typing in. There's some other ones you're going to need too. SDL net for when we're doing our networking stuff. SDL underscore image for doing the image one, like that. And then one other one we'll need. Mixer for when we start doing the sound later on, which we haven't done yet. But yeah, we need SDL underscore mixer too. So yeah, that's the ones we need, and they are a must, otherwise it's not going to work. Say OK to that. Cool. Click here, save it to the project. Hopefully it stays. Don't know why it keeps disappearing on me like that. But anyways, maybe I'm forgetting to save something or whatever, I don't know. And we can just apply these to each one of these things here. But anyways, we need that, and then we need to define a function so that we can load our textures with. And it's easier than it may sound. We just need to do a GLU int here, which is, you know, GL unsigned int for a return type. And our function name is going to be load texture here, because we're going to load a texture. And we're going to pass in a constant char star, which is a char string, basically a string. We're going to pass in, and we're going to call it a file. We're going to do file here. Could also have done this as a string too, but oh well, it's a char star, so it's a character array. SDL underscore surface here, star, and then surface. This creates an SDL surface so that we can apply our texture to it. So that way we can load it into OpenGL. And it equals img underscore load, open close parentheses, file inside, and a semicolon. And that works great. It's going to let us load in that file. And in this way it's going to basically let us load in any kind of file we want. This way we can load JPEGs, Targas, you know, PNGs, you know, gosh, just TIFFs, you name it, everything you can imagine practically. And it works across all the different operating systems. So yeah, img underscore load is the SDL command that's why we were doing the SDL image.h file. That's why we have that in there. So that way we can just load just about anything you can imagine. And that's all there is to that command. It's that simple. So now the image is loaded. It's really any kind of image type, and pass it in and it's loaded. Alright, so then we do a GLU int. Here is a basically OpenGL unsigned int texture. We're going to use this as our texture ID. I'll tell you what, I'll call it text ID, just making sure. Just to make things, or I'll just call it texture ID like that, just to make things a little more clear than what they are. Okay, so GL pixel store I here for integer, GL underscore unpack underscore alignment, comma 4 here. Alright, so we're going to store it as integers. We're going to unpack our alignment with 4 here for RGBA. So we need to get it laid out properly, because different formats can have different orderings of the colors. So it needs to be ordered properly. GL gen textures here, 1 comma and texture ID here. So this is going to allow us to generate our textures and assign it to a particular texture ID here, and this generates a space for that texture ID, and it's going to assign it a number, and the number it's going to assign here is 1. So we're generating our textures. After we generate our texture here in OpenGL, we need to bind it to something, and we're going to bind it as a GL texture 2D. So we're going to set this texture up as a 2D texture, and this is going with the first texture in the texture stack here for our GL bind texture, and so it's assigning this as a 2D texture in memory space, and it's number 1 texture on the stack, because you can have multiple textures layered if you like. SDL underscore pixel format here, and then star format. So let's just do our pixel format here, and then we're going to do surface and then the format. So we're getting the format of the texture of the surface here. Okay, so if format a mask here, and this be alpha mask. So basically, if it's RGBA, we want to do a GLU build 2D bitmaps. So we build 2D bitmaps, GL texture underscore 2D, because we're going to do 2D texture. This is going to be RGBA, so it's got 4 components to a color. R is 1, 2 is G, B is 3, and A is the 4th one. Surface W, this gives us the width of the surface, or the width of our image in this case. Surface H is going to be the height of our surface. And then GL RGBA is going to be what? It's going to be the OpenGL's red, green, blue alpha here for the OpenGL. So we're setting it up to be, you know, a match. And then GL unsigned byte. And then we're going to assign the surface pixels to this. And that gets our surface pixels to be built as a 2D bitmap, which is very cool. And then else, so if it wasn't format A mask, then it's got to be RGB. In which case we're going to do the same function, but this time we're going to do same as there too, but this time we're going to do 3 for RGB, because we don't have the A, we don't have the alpha. And it has a surface width, surface height, and then RGB, and then GL unsigned byte, and surface pixels. And there we go. And that lets us do RGBA and RGB. And then we're going to set up our free our surface. That's what we're done with it, so it doesn't eat up memory. And then we're going to return our texture. So this gets rid of the surface eating up RAM. Okay. And down here in the knitGL, something else you need to pay attention to. We also need to add GL enable. And in this case, I'm doing GL underscore alpha test. The reason why is because we have images with alpha transparencies, and so we want those parts of those images to become transparent in our actual model. GL alpha func here. This is our function for doing our GL transparency here. In this case, it's GL underscore greater, comma 0.5. This means if anything's greater than 50%, then it becomes transparent. Otherwise, it doesn't. GL hit, and there's plenty of functions, different ones to choose from on that. And then the other thing we're going to be doing is GL enable texture, because we need to enable textures, otherwise we won't have textures. And then we're going to do our text ID, because remember it has a return type of what? GL uint, which is our unsigned int, right? This is our texture ID here. So text ID equals load texture, and then I'm telling it I want to load this particular texture. Now where did I get this texture? Well, A couple things here we want to check out besides that. Hold on a second. Yeah. So OpenFrag is this open source, basically first-person shooting game, and since it's open source, so are the textures. And so you can get the textures if you so desire. This is the listing from Blender site here, where it was put up for everyone to download them. And the place where you download it at is http://sourceforge.net/projects/openfrag/files/artwork with a capital A there for the artwork that matters, and then Slayer with capital S space texture space pack, all lowercase for the rest of that, capital S for Slayer, slash openfrag_slayer.rar/download. And that will let you download that library. Also, you may be interested in free sounds here too. And since this is open source, you can use it for whatever you want. This is a little bit different license. You can use it for non-profit type things on this particular setup here for the sound. But if you want to use it commercially, you can if you mash up your audio files. So basically, if you do some audio mixing on it and intermix and create your own sounds from these sound files, then you can use it commercially. So that's a really good resource also. So feel free to also hit up http://www.freesound.org/samplesview capital V there single capital S there .php id for ID here equals 25481, and that will, if you sign up and everything, then you can download all kinds of sound files that you can then do mixing on or whatever. Okay, so that's a couple of really useful resources there. And also over here I have the texture image, and you can see all the different types that you are allowed to use for formats and everything. And this comes straight from the OpenGL website and their docs for their documentation. And you can see all the different ones you're allowed to use for this, for formats. And it goes over the width here, and the height, and the border here, and format, and the type, so on and so forth, and the data. It specifies the image data pointer in memory. Yep. And it has a description on it too if you want to go in more detail and stuff. And here's a different, I was talking about doing RGB could be done in different orders. There you go. GL bind texture. GL bind texture. Here we got our target. We got our texture here, like so. And we also have our GL gen textures here too. GL gen textures are over here. Number of texture names to be generated, and then the texture array. Textures or names are stored, so that way they get generated. So that way you can have multiple textures generated. And here's the GL build 2D bitmaps here, along with this target internal format, width, height, format, type, and data. And here they got an explanation of each one and what's available and what's possible to do, and all the constants that are allowed, so on and so forth. So also reading there's a better way to do this inside of OpenGL 3.0, but I'm afraid it may not be compatible with the free player of VMware Player, so I'm not using it right now. But it's called GL Gen Bitmaps. So that one's really good also, by the way. Oh, I'm sorry, GL Generate Bitmap. This is a better method, but it's part of OpenGL 3.0, and so it may not work on the virtual machine. So for that reason, I didn't implement it. But you can use this in place of GLU build 2D bitmaps. Okay. With that said, back to the code. Alrighty. And that covered a lot of stuff right there. one other thing we need to do. We need to, so we already called this texture to be initialized and loaded. And so we want to load our textures at the beginning of the simulation and not repeatedly over and over again so it doesn't eat up memory and computation power. So we load it into memory and load it into OpenGL, and then thereafter we don't have to worry about it. The only time I'd change this around is if I was doing dynamic loading or something of that nature, where I'm loading and unloading assets in the game engine on the fly as needed. Okay, so with that, we don't have to do anything as far as the cube goes. Because this is a state machine, it's going to automatically apply that texture. So because we draw it directly after the texture, it gets drawn on here on the cube. And we can verify that. Oh yeah, forgot to change this up for the ID also. That's rather important. Very, very important. Matter of fact, I need to do it over here too while I'm at it. Save. Alright, and rebuild. And there we are. We're back to our textured cube. Yep. Next we'll look at how to do the actual CD playing and accessing the CD-ROM drive. Okay, so let's do that now. Okay, so before we ended up back up here, I did delete the need for the track integer variable here. I recoded it with a static variable inside the functions to make it easier. So, okay. So let's have a look at doing the CD-ROM player. As soon as I get to it. Alright, got a lot of code at this point. Good grief. Alright, play CD. Does what it sounds like. This function plays a CD. Gets a whole lot of extra statistics and everything. We're just doing a void here and then play CD, open close parentheses, open a curly brace here. Static space int space track count equals 0 semicolon. Now since this is going to be in our overall loop anyways, I just thought it'd be a good idea in order to just loop it as a static variable. I mean, we did this previously in some other areas too, I think, in this code if I'm not mistaken. So this is a great trick that's used by a lot of people, and lets you increment a function that's going to be inside of a loop without having to you know, do anything special as far as workarounds or whatever. It just makes it easy. So this value is going to get left here in memory after the function closes out, so it doesn't leave the stack of memory until the program closes. So because of that, it's going to retain its value. And that means that this variable can be incremented between different calls to the function. So thereby, you know, say this is 0 the first time it runs through the function, the next time it runs through the function it gets incremented to 1, and then the next time, and the next time, and etc., etc. Each, you know, time it increments more and more. And the first time this variable, this function is called, this variable is declared and it's assigned 0. Thereafter, it's not called. This doesn't happen again. You know, it just resides in memory. Alright, so CD equals SDL underscore CD open close parentheses, 0 inside, semicolon, and this is going to make it open up for our CD-ROM. If CD here equals null, you know, so if there's no CD-ROM there, you know, nothing's there. If they don't have a CD-ROM player, that certainly causes a problem too. fprintf here, standard error, could not find data on the CD-ROM. Is the disk in your CD-ROM player? You know, and so I'm asking the user, hey, did you forget to put the CD in? So, you know, that's kind of nice. Just to let them know. Right now it's going to a file, but in Linux it's going to go to the screen. Of course, if we're doing this in our crazy 8 GUI, we could actually have this appear as an error message to the user. And this probably will end up coding out later on these different graphical error messages as message boxes and stuff like that, as that's pretty standard in programming anyways. Open close parentheses here around this and a semicolon here, close curly brace, SDL underscore CD status, open close parentheses, CD here, semicolon. Report information about the CD, fprintf here, open parentheses, std out, comma, in quotes here, information on the CD in the drive, dot here, slash in, close quotes, close parentheses, semicolon, fprintf, open parentheses, std out, comma, open quotes here, id, colon, space, %d, slash in, close quotes, comma, cd, arrow here, id, close parentheses, semicolon. Okay. This gets the CD-ROM ID. And this right here for our SDL status here for our CD, this lets us find out the status for our CD in this way here. Okay, and that's going to set the status value inside of the CD here. So that's why we can access it later on down here. So that allows us to then have the data put into this variable here where we can now access it within the switch statement. Switch statement is nice, clean, easy, and fast, and most of the programmers using SDL, as from what I've seen from examples for everyone, is using pretty much case statements. If not, then if, but case statements is the most popular method, and I think it's the fastest, cleanest method too, so it's probably the best way to go actually. So I'm not going to break strides and go off in a different direction with like ifs or whatever here. Switch here, CD status here, close parentheses here with an arrow, of course, because we're dereferencing this pointer, and then we're saying, you know, that value for that variable as it points to that location. Open curly brace here, case here, CD underscore stopped, colon, fprintf, open parentheses, std out, comma, in quotes, CD-ROM status, close, colon, and then stopped here, slash in, close quotes, close parentheses, semicolon. And it's basically letting us know that CD-ROM status is either stopped, paused, playing, error, or tray is empty. And look, it's pretty much the same thing over and over again. Only thing is, I've said if it's stopped, let's play it instead. So SDL underscore CD play. So hey, if we checked out the status that's stopped, we need to make the CD play. Pass in CD here, the CD arrow track count, so we know what track to play out of the tracks. Offset here, a dot offset, and then CD track here, track count dot length. So we have our offset and our length to play it. Break, of course, if these are zeros, it's not going to play anything. Break, semicolon, case CD underscore pause, fprintf here, open parentheses std out, comma, in quotes here, CD-ROM status here, colon, paused. You can see it's the same thing repeated over and over again. Close parentheses, semicolon, of course we're going to break, so that way once we find what we're looking for, we go ahead and exit the structure and we don't keep looking for it. So that takes care of that one. Same thing exactly, except we're just going to do, you know, copy and paste it. Change CD underscore pause to CD underscore playing, and change pause to playing. And same thing over here. CD-ROM error, you know, copy and paste the previous one above. Change the playing or pause, whatever, to error, you know, whichever one you copied here, and then change the playing or pause to error. Same thing again, paste again down here. Change it to tray empty, and say that the tray is empty, so they know that the tray is empty for the status. Fprintf here, standard out. Current CD-ROM track. So this lets us know where we're currently on the track. I wanted to say that first before. I figured that'd be like one of the first things you'd want to know is what track you're on your CD-ROM. So I put it first, and then I said what frame it's on. So you know, current underscore track is going to be current track. Current underscore frame is current frame, and these are standard values within inside of SDL for accessing you know, values with the CD here. Remember the CD variable? It's created here as SDL CD. So yes, those are members of SDL CD, or not structure anyways. Alright, hold on a second, getting back to where I was. Okay. And we got track number here. So we know what track we're on. and right here is the total number of tracks. I don't know, I might move that one up above. Whatever. I don't know which way I like it the best. Switch here, CD, arrow here, track count, dot type. So this is the type of tracks. It is it a data track? SDL underscore data underscore track. It lets us find out if it's a data or not, or if we got audio. fprintf here, standard out. File. CD-ROM data type for tracks, colon, is data. Close parentheses, semicolon, break, semicolon. You can just copy and paste that one down below and change data to audio and change data to audio again, and there you go. Close curly brace, close curly brace for that case structure, for that switch case structure. And then I don't know, fprintf here, standard out, length, colon, %d here, frames, find the number of frames for the length here. And then we get the length of it, and then we get our offset here. And if track count is less than or equal to CD num tracks here, so if it were less than or equal to our track count for the overall number of tracks, then we're going to go ahead and increment our track count. And the reason I put this at the end is because remember we initialize this thing when it first starts out at 0. So if I put it underneath this, guess what's going to happen? Yeah, it's going to increment it to 1 until we never actually reach 0 until this thing goes through the entire set of tracks. So I have it start at track 0 this way, I have it go through all the way through the code, and then I increment it at the end. This way it's not going to be a conflict as far as that goes for its incrementing aspect. So if track count here is less than or equal to CD for num tracks, there you go, it increments it. Also, if track count is greater than CD num tracks here, then track count is equal to 0, semicolon. So this way we're going, okay, so if we reach the very end of the number of tracks, then we're going to start back at 0, in which case then we're going to go ahead, and this causes us to continuously loop through the tracks on the CD. Basically is what happens. As long as the game continues to play, it just continuously loops through the tracks. And for streaming this off as music into like the SDL mixer or something like that and playing the music from the CD, then we can continuously just play the music off the CD over and over again until the game closes. One last thing to do here is create a function for closing the CD. Void close CD here, open close parentheses, open curly brace here, SDL underscore CD close, and then open parentheses CD, close parentheses, semicolon. And that's the fprintf here, standard out thing telling us that, hey, the CD is getting closed. Close parentheses here, semicolon, close curly brace here. And in this code structure, buried in this code structure, right after get joysticks, I went ahead and threw in play CD, semicolon here, so we're playing it, and then I closed out the CD so that way it would get closed out too, along with the joystick and quitting of the system. Alright, so that covers the CD aspect of SDL and how to access it and do all kinds of functionality on it. With this, my name is Nate Nestler, and this is for Hyperactive Studios. Thank you very much.